Okay, problem 1, we have a hyperbola, and this is really problem 1A. I'll do the example that goes with it. We have a hyperbola centered at 0, 0. We have vertices at plus or minus 2, 0. The foci are plus or minus 3, 0. What is the equation of the hyperbola? And then we want to sketch what our hyperbola looks like. So first of all, let's sketch what we know about our hyperbola. We'll draw our x and our y axis. We know we have our hyperbola centered at 0, 0. We know the vertices are at plus or minus 2, 0. So we have a vertex here and here. And our foci are at 3, 0 and negative 3, 0. So keep in mind that that focus is always going to be inside our hyperbola. We have a focus here and a focus here. Now that tells me that my hyperbola has to go sideways. Okay, and I am actually going to draw this in pencil for a second until we get a better idea of what our hyperbola actually looks like. If I can find a pencil. So our hyperbola is going to go sideways. And that's about all we know. So since my hyperbola is going sideways, if I look at my general form right above us, that tells me that x squared has to come first in my equation. Then I'm going to have x squared over something minus y squared over something equals 1. And this first number with hyperbolas is always going to tell us our vertices, and we know what our vertices are. We know our vertices are at 2 and negative 2. So this first number underneath our x squared is 2 squared, which is 4. Okay, so that's what we know right now. We have x squared over 4 minus y squared over something equals 1. I don't know what b is though. B tells us the other length of our central rectangle. So right now, our central rectangle, we don't really know what this looks like. I don't really know how high the central rectangle goes. But wherever the central rectangle goes, if I draw it in like this for now, wherever the central rectangle goes, this height of the central rectangle, the origin, and our vertex form our right triangle. I'm going to pull this right triangle out to the side, and we'll work with it separately. Looking at my right triangle, I don't know what my height is. That's what I'm looking for. But I do know that this length from my origin out to my vertex is 2. And this hypotenuse, just like with ellipses, is the origin to the farthest point. Okay? Origin to the farthest point here is to our focus, and that distance is 3. So I have a right triangle with sides x, 2, and then the hypotenuse is 3. Use the Pythagorean theorem here. X squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. X squared is 5. X is plus or minus square root of 5. Okay, and I actually drew that in pretty close here. Square root of 5 is just over 2. So that tells us the height of our central rectangle is the square root of 5. And that is what goes into our equation here. Square root of 5 squared is the 5. Okay, we got our equation figured out. X squared over 4 minus y squared over 5 equals 1. Answering this part of the question. We also want to sketch the hyperbola, And we have most of our sketch done here. The only other things that we want to include when we have our hyperbola, we got our central rectangle's height drawn in. We want to include the diagonals because the diagonals of our central rectangle show us the asymptotes for our hyperbola. And this is why I drew my hyperbola in pencil, because I know I'd probably have to erase this part. So these are the asymptotes for our hyperbola, which means that my hyperbola is going to get closer and closer to those asymptotes on each side and not cross. So there's our sketch.